My dear friends, welcome to my channel. Myself Gaur Bharat Kumar, working as assistant professor in the department of CSC. In today's session, we will discuss about a two-player game in artificial intelligence. Actually, the two-player game in artificial intelligence is related to the minimax searching algorithm. Already in the previous session, we are covered how to solve the minimax example problem. In today's session, we will discuss about some explanation regarding minimax searching algorithm. Actually, the minimax searching algorithm is a recursive. Here we are applying the backtracking process which is used in decision making and game theory. It provides the optimal solution for the player. Here we are considered two players. One is considered as the maximum player and another one is considered as the minimum player. Actually, this is related to the game theory problem. Here these problems are related to the two players game problems like chess game, checkers game, tic-tac-toe game, like that. Here we are apply the two players play the game. One is called as the maximum and another one is called as the minimum. Here both the players are fight for the winning here. Definitely the opponent player gets the minimum benefit while they get the maximum benefit. Each and every player fights for winning only here. So both players of the game are opponent of each other, where maximum player score select the maximum value. At the same time the minimum player will select the minimized value. Here we are applying the depth first search algorithm data structure. Already we know what is the meaning of depth first search. In the depth first search algorithm, first we will visit the root node, next we will move to the left child, then only we will move to the right child. Here we are apply the same process. In the minimax algorithm proceeds all the way down to the terminal node of the tree, then backtrack the tree as the recursion. Here at the depth 0, that means last level, here we will in the minimax searching algorithm we will consider those level as the terminal nodes, and here we will consider the random values for the terminal nodes, those called as the terminal values. So first here we are apply the pseudocode. After that we will move to the example. Suppose we have depth 0. Depth 0 means only the terminal nodes are available. So definitely those values are the node values. So here we can't apply any minimax searching algorithm. Suppose we will consider the maximizing player. This problem is related to the two player game. Definitely one player is related to the maximum player and another player is related to the minimum player. Suppose we will consider the maximum player. So here initially we will assume the maximum value is minus infinity. Here each and every child compare, and here we evaluate the value. Here we will find out the which is the maximum value. Then finally we will return the maximum value for that particular node. Now we will discuss an example also, no problem. So suppose we will consider the minimized player. In this situation we will consider the minimized value as plus infinity. Here also we will compare each and every node of that particular level. Here we will evaluate the minimum value. Okay, finally we will return the minimum value for that particular node. So we will start the working process of minimax algorithm. The working of minimax algorithm can be easily described using an example. Here we will consider three levels of information. So please observe the example also here. So in this example there are two players. One is considered as the maximer and another one is considered as the minimizer. Here definitely the maximizer will try to get the maximum value. At the same time the minimizer will try to get the minimum value. Here we are applying the depth first search algorithm. First we will start with the parent node, next move to the left, finally we will move to the right child. At the terminal, that means at the depth 0 we have here terminal nodes are available randomly. Here we will consider the terminal values. Okay, so with the help of backtracking now we will start how to solve the problem. So if you want any information how to solving the process, please visit my previous video. In that video I am clearly explained. So here the top capital A related to the level 0, BC are related to the level 1, next level, level 2, level 3. In the level 3 we have the terminal nodes are available. In the terminal nodes, each and every terminal node have some random values. Here I am choosing. Okay, so here this is problem is related to the two player game. That's why definitely one player is the maximum player and another one is the minimum player. So that's why level 0 is considered as the maximizer. Next level, that means B and C considered as the minimizer alternatively. Next level we will consider as the maximizer, like that. Suppose we will consider level 0 as the maximizer. Next definitely we will consider the level 1 as the minimizer. Next maximizer, minimizer, like that. Suppose we will consider the level 0 as the minimizer. In that situation, next level we will consider as the maximizer, next minimizer, maximizer, like that. So here in the first step, the algorithm generates the entire game tree and apply the utility function to get the utility values for the terminal states. In the below tree diagram, let's take capital A is the initial state of the tree. Suppose maximizer takes first turn, which has worst case initial value, that is minus infinity. Here we will consider the maximizer player as minus infinity and minimizer player as plus infinity. Okay, now we will start the problem. So now we will apply the backtracking. Suppose now our aim is to find out the capital D value. Here D, E, F, G, that is the level 2 values. So with the help of level 3 values, now we will find out the level 2 nodes. First we will find out the capital D, next capital G, capital F, capital G. These nodes are related to the maximizer. Please consider the capital D. What is the chain nodes here? H and I. What is the maximum value of H comma I? Minus 1 comma 4. What is the maximum value here? Max of minus 1 comma 4 means 4. Okay, are you understand my point? Suppose we will consider the capital G. The chain nodes are JK, values are 2 and 6. Which is the maximum value? 6. Here initially the maximum value is minus infinity. We will consider the may or may not be minus infinity because negligible. At the node F we have the chain nodes L and M, minus 3 and minus 5. The maximum value is minus 3. Finally at capital G, the chain nodes are N and O. The values are 0 and 7. Okay, so which is the maximum value? 7. Next, now we will find out the values of level 1 values, that means B and C values. So what is the chain nodes of B here? D and E with the values 4 comma 6. Here B and C are the minimized level, so that's why here we will consider the minimum values. Okay, so which is the minimum value from 4 comma 6? Definitely 4 is the minimum value. That's why node B value is 4. Coming to the C, the chain nodes are F and G. The terminal values are minus 4, minus 3 and 7. Which is the minimum? Minus 3. Okay, so next finally our aim is to find out the parent node, that is capital A. Here the chain nodes are B and C. Capital A is related to the maximum value, maximum player. So which is the maximum? 4 and minus 3. 4 is the maximum. This is the process of minimax searching algorithm. So if you have any doubts regarding the example, please visit my previous video. Here we will consider the properties also. Definitely at the time of each and every algorithm properties, we will consider the complete optimal time complexity and space complexity. So now coming to the complete property, definitely the minimax algorithm is the complete. It will definitely find a solution in the finite search tree. So that's why this is the complete algorithm. It produces the optimal solution also, because if both opponents are played optimally, definitely the maximum player selects the maximum value, minimum player selects the minimum value. Definitely it produces the optimal solution. Coming to the time complexity, So here the time complexity of minimax searching algorithm is upper bound of b power m because it performs the depth first search. So the time complexity is a minimax searching algorithm is upper bound of b power m, where b is considered as the branching factor and m is considered as the maximum depth of the tree. So at the same time the space complexity is also depending on the branching factor and maximum depth. That's why the space complexity is upper bound of bm. Coming to the limitations, here we have some disadvantages are also available. So the first drawback is, suppose the minimax searching algorithm is that it gets really slow for complex games. Here we will consider the only three level of nodes only. Suppose we will consider the 9 by 9 grid, 3 by 3 grid. Definitely at the situation we will face a lot of problems. So that's why it is not suitable for the complex games. Another disadvantage is this type of games has a huge branching factor and the player has a loss of choice to decide. So the time complexity and space complexity is depending on the branching factor. That's why the minimax searching algorithm takes a huge branching factor. That is also one of the disadvantage. Here how to rectify these disadvantages? Definitely these disadvantages are rectified by alpha beta pruning. In that we will follow some pruning limitation. With the help of pruning we will get the best result compared to the minimax searching algorithm. So that's why in the next session we will discuss about the alpha beta pruning in artificial intelligence. Thank you very much for watching. Thank you.